Okay, we have hyperbola standard equation. X square upon a square minus y square upon b square is equal to 1. And the diagram is x-axis, y-axis. You have two directrix. Then you have the curve. Distance from focus is more than that of from directrix. So you have one branch of hyperbola going like this. Let me change the colors for different branches. And I need one more color. And this is your focus. Focus. S, Z, A, C, Z dash, A dash, S dash. Correct? Okay, up to this point we had done, we had discussed the symmetry part of the hyperbola. Then we have found out equation of directrix, coordinates of different points, a by e comma 0, 0 comma 0, minus a by e comma 0, minus a comma 0, and minus ae comma 0. Okay, and then we were struggling to get what do we mean by b. Basically, we wanted to solve y-axis, which is x is equal to 0, simultaneously with this hyperbola, and we ended up getting y square is equal to minus b square. We will have to figure out what do we mean by this. But suppose we ignore this minus sign, then we will get y square is equal to b square, and as I said, this b can be smaller than small a or can be greater than small a. Why is it blinking? So let us assume that this distance is a, our b is somewhere here, numerical value, but it is not actually visible. Okay, a dash is called transverse axis. And b dash is called conjugate axis. Okay. Then comes the question, suppose there is any point P on the hyperbola. Suppose there is a point P on hyperbola, SP upon PM is our eccentricity. So what is focal radius? How much is SP? So this is your question number 1. SP is equal to, if P is x dash comma y dash, then how much is SP? So पटापट उत्तर काढायची आणि मला दाखवायची. Okay, SP is equal to EPM Pm is x dash minus a by e into e x dash minus a. Similarly, s dash p is equal to this. And therefore, the obvious property that we get is s dash p minus sp in this case. So what you can consider is bigger minus smaller, or you can consider this as absolute value. This is third property of hyperbola, or maybe this is the characteristic of hyperbola is equal to 2. Like in case of ellipse, the total distance traveled from focus till any point on ellipse and back to another focus is constant. PA plus PB, PS plus PS dash was constant. Here the difference is gone. So there is a similarity and difference between ellipse and hyperbola. Therefore, they go hand in hand, and both of them need to be studied actually simultaneously. But we have completed ellipse and now we are studying hyperbola. But you need to remember them simultaneously. I mean, this is in case of ellipse, this is in case of hyperbola, this is in case of hyperbola. Otherwise, they will get mixed up, and you will use wrong result for a wrong curve. Okay, next. Find length of lattice rectum LL dash. Then L dash happens to be this fellow. Rangi berangi. This is your lattice rectum LL dash. How much is distance LL dash? I mean, everyone can find it out. We will not wait for that. Fifth is going to be parameterization. Okay, this is where I will wait. You have to suggest some parameterization for hyperbola. Okay, length of lattice rectum is 2b square by 8, same as that of ellipse. Parameterization, as many of you know, it is a sec theta comma b tan theta. Because of the identity, I mean trigonometric identity, in case of ellipse it was summation of two squares equal to 1, therefore we said we will assign a cos theta to x and b sin theta to y. That was very obvious selection of parameterization. Here it is difference of two squares is equal to 1, and therefore either sec square minus tan square is equal to 1 you can use, or cosec square minus cot square you can use. But then in case of ellipse, identification of that theta was easy relatively. Here you need to figure out in the diagram what do you mean by theta, and how are you going to control the theta value to get different points on hyperbola. So now that is why I give you some time to think. See, trigonometrically you are fitting something in the equation and you are getting is one part of the story. Second part of the story is that you should be able to identify that particular angle in the diagram. And every time we are confused with hyperbola, we are going to take help of ellipse. Because in ellipse, everything was real because it is summation of two squares adding up to 1. There was no imaginary thing happening in ellipse. Everything was in front of you. It was bounded curve. It was closed curve. It was symmetric curve. Everything went fine in case of ellipse. Now hyperbola is going to trouble us, but hyperbola will provide us some additional information also. Therefore, whenever we are in trouble, as far as hyperbola is concerned, we will look at corresponding thing in ellipse. So in ellipse, when we parameterized, we given lot of importance. We have given lot of importance to auxiliary circle. circle with center at origin and radius equal to small a. We have given a lot of importance to that. So maybe we will have to have auxiliary circle in case of hyperbola. That is what I have tried to draw. Now, basically you want your point P, this is your N, foot of perpendicular from P on X axis. So your X dash is basically Cn. X dash is Cn, and we want Cn to be equal to A sec theta, that is A upon cos theta. That is what we want our Ca to be. And our A is the radius. So if we do little bit of trials, we know complete Pythagoras theorem, etc. So draw tangent from N to the auxiliary circle. The point of contact here is the point on circle. Join it with center. Let this point be U and this angle be theta. Now, if we try to write down Cn, this is small a. Therefore, Cn into cos theta is equal to A. Can you see that? A into cos theta is equal to Cn. And therefore, Cn is equal to A upon cos theta. That is the parameterization and geometric location of eccentric angle theta in the auxiliary circle. So, this angle theta, and if you join Cp, whatever angle you get, they have nothing to do with each other. They are going to be totally different angles. Unless you have special points like theta is equal to alpha when it is A, point A, 0, both of them, etc. So special points. When theta, okay, so if Cn is equal to A upon cos theta, then for getting distance Pn, which is your y coordinate, we substitute this value back into the equation and we get y coordinate as b tan theta. Okay, so what is Pn? Actually, Pn distance is uniform compression of Un in the ratio b upon A. You can see that Un is equal to A tan theta, correct? And Pn is equal to b by A times A tan theta, which is b tan theta. So it's a uniform compression with the ratio b by A. Un you compress to get distance Pn. This is what makes hyperbola little complicated, because in ellipse eccentric angle is not the angle Cp, agreed, but it is near, it is above, it is you join corresponding auxiliary point on the circle and you get the theta value. It was easy to visualize in case of ellipse, but unless and until we are very clear about what we are doing in hyperbola, it is little difficult. Okay, so this is what is the parameterization. You can actually do A cosec theta and B cot theta also, but things are not that easy if we do that kind of parameterization. You will find that A sec theta comma B tan theta seems to be working. Theta is under control. Now, if theta, if 0 is less than or equal to theta is less than pi by 2, in that case, which arm of hyperbola will you get? Now what procedure you need to do is, if the angle is theta, that means from here you are allowed to draw Cu from here to here, 0 to pi by 2. So if you draw CU, procedure is draw CU, second draw tangent. What is this? At U to auxiliary circle. Let U intersect x-axis at N, and then for locate point on hyperbola. Now this is important. Please pay attention. If the theta angle is between 0 to pi by 2, everything is fine because everybody is positive, and therefore as shown in this diagram, this arm, this red arm that I have drawn, arm number 1, we will trace arm number 1 as theta moves from 0 to pi by 2. What will happen at pi by 2? It is better if we don't imagine at the moment because discipline. B tan theta is going to be undefined. So we keep pi by 2 little aside. S2, if theta is between pi by 2, strictly greater than pi by 2, and maybe, can I make equal? Sec 0, yes, equal to pi. Which arm will we get? Understand this. Now I am drawing some angle here in second quadrant. This is our theta now. This is your point U. What is the procedure? Draw CU, draw. Draw tangent at U. Okay. Draw tangent at U. You got point N. From N, go to hyperbola. So from N, I have two choices: to go here or to go here. So let me call this as P1. I want to locate P2. Will this be P2, that is in second quadrant, or will this be P2, which is in third quadrant? What is your point? What is your answer? What is your thinking on that? Okay, this procedure will tell us what is x coordinate, n. That is for sure. That is correct x coordinate. But we need to use our mind to find out what is y coordinate. So the simple question is whether P2 is in second quadrant or third quadrant. And the answer is pause. Okay, so if pi by 2 is less than theta is less than pi, the arm in third quadrant will be traced by hyperbola. If the angle is between pi to 3 pi by 2, the arm in second quadrant will be traced. And if the angle is between 3 pi by 2 to 2 pi, the arm in fourth quadrant will be traced. So quadrant 1, quadrant 3, quadrant 2, quadrant 4. That is how this point will move. And at pi by 2 and 3 pi by 2, the value will go to infinity. Okay. Find equation of chord. A1, x1, y1, a2, x2, y2. Answer is x minus x1 into x1 plus x2 square minus y minus y1 into y1 plus y2 on b square is equal to 0. Same procedure that we adopted for parabola and ellipse, you will get it. Problem number 8. Equation of chord A1 theta 1 A2 theta 2 in terms of parameter theta. RHS cos of angle, cos of half angle. It is x upon A cos of theta 1 minus theta 2 upon 2 minus y upon B sine of theta 1 plus theta 2 upon 2 is equal to cos of theta 1 plus theta 2 upon 2. This is the equation of chord A1 theta 1 A2 theta. Next, find the equation of tangent. At Ex1 y1, which is x1 upon a square minus y1 upon b square is equal to 1. 10. Equation of tangent at p theta is equal to x sec theta upon a minus y tan theta upon b is equal to 1. Simple. Then 11. Find point of intersection of tangent. Tangents at P1 theta 1 and P2 theta 2. Get the point of intersection again in half angle form. Should be easy to remember. Okay, answer for point of intersection is a cos theta 2 minus theta 1 upon 2 divided by cos theta 2 plus theta 1 by 2, comma b sine, here it is theta 2 plus theta 1 by 2 divided by cos theta 2 plus theta 1 divided by, this is your point of intersection. I am not deriving them because I think we have done that work in ellipse, exactly similar. 12, point number 12. Y is equal to mx plus c. Touches hyperbola at, if and only if, fill in the blanks. Okay, point of contact of hyperbola is minus a square m by c comma minus b square by c if and only if c square is equal to a square m square minus b square. By couple of methods, comparing coefficients or by discriminant method. Find auxiliary solution, equation. To find the slopes of tangents. Passing through x1, 1. mx plus minus root a square m square minus b square. This is your line. It should pass through x1, y1. So in case of x, you should write x1. In case of y, you should write y1 and simplify and get quadratic equation in m, which is x1 square minus a square times m square minus 2x1 y1 times m plus y square plus b square, y1 square plus b square is equal to 0. This is your auxiliary equation. If you happen to draw two tangents, how many tangents are possible? Two tangents. Now, it depends whether it is real, imaginary or coincident, where on x1, where x1, y1 is present. And if imaginary, then discriminant of this is going to be less than 0. Shall we check when do we get imaginary tangents? If the x1 square y1 square minus 4 times x1 square minus a square into y1 square plus b square is less than 0. What do we mean by this? इथे पण 4 point. So 4x1 square y1 square minus 4x1 square y1 square minus 4x1 square b square plus 4a square y1 square plus 4a square b square, right, should be less than 0. So first term gets cancelled. I just want to show geometrically where this, if the point is in this zone, the tangent is going to be imaginary. This gets cancelled, and therefore what you get is 4 gets cancelled, and are we getting something? X1 square upon x square minus y1 square upon b square. So if I take it to this side, x1 square by a square minus y square is equal to a square is, this should be greater than 1. Yes or no? Yes or no? Equal to 1 is point on the hyperbola. If LHS is greater than 1, because I am taking this fellow to RHS, this fellow also to RHS, and then dividing by a square b square, therefore this. So in this case, your delta is less than 0 and imaginary tangents. Okay, so point x1, y1 should be such that they make this ratio greater than 1. So let us go to the diagram and find out which particular zone we will have this. Say if the point, let us put point 0, 0. No, 0 comma 0 is a very special point. Let us take any point on x-axis. Say, suppose we want to draw tangent from this zone. Is it going to be possible? Any representative point here will give us, say, AE comma 0. Suppose from focus we want to draw tangent. So a square e square upon a square minus 0 is how much? Is greater than, what is the condition that we have got? It should be greater than 1. If it is greater than 1, then we cannot draw real tangent from that point. So we have point focus in this part of your hyperbola. So a square e square upon a square minus 0. Is it greater than 1? Yes, our eccentricity is greater than 1. Therefore, this is greater than 1 and hence no real tangent. So we check one point and say that this area and this area you won't get the real tangents, and if the point is all hyperbola you will get coincident, and in this zone, remaining zone, if you have point anywhere you will get two tangents. That is what theory of quadratic equation tells us, which is okay, which is geometrically also it is correct. Okay, another thing that we do with our auxiliary equation is, what is the locus of intersection of perpendicular tangents? 14. Locus of point of intersection of perpendicular tangents. What is the point of intersection of perpendicular tangents? What we should do is, where is our auxiliary equation? Here. Product of the slopes is -1. So y1 square plus b square upon x1 square minus a square is equal to -1. That makes it x1 square plus y1 square is equal to a square minus b square. Replacing x1 by x and y1 by y, we get desired locus. So it's a circle. X square plus y square is equal to a square minus b square is our director circle. That is your director circle, and wherever it is, I mean, it is going to be less than that auxiliary circle that we have drawn because it is a square minus b square. That is the locus of perpendicular tangents to the given hyperbola. Good. Four meanings, interpretations. Of t is equal to 0. We have done this. 16. Y is equal to mx plus c is polar. Then minus a square m by c comma minus b square by c is polar. Correct. Done. 17. Polar duality. Done. We have done it for general form. 17. 18. Let me change at least color. 18. Joint equation of pair of tangents. SS1 is equal to T square. 19. Equation of chord in terms of midpoint. T is equal to S1. Then see the advantage now. If you would have not done that degree 2 equation theory, all these things required to be discussed in case of hyperbola. But because we have got a master stroke at that time, everything is done 20. Maybe now find the equation of normal. At Px1y. P1 x1 y. चला complete करा. Formality. These are the rituals that we are supposed to complete. Okay, for a change, let me derive the equation for normal. X x1 upon a square minus y y square 1 upon b square is equal to 1. So slope of normal is going to be this y1 upon b square x plus x1 upon a square y, and if you substitute x1 y1 in LHS, you should get RHS, which is y1 x1 upon b square plus x1 y1 upon a square. Is that right? Is this correct up to this point? So we bring this, some simplification would take place. Therefore, finally, if we bring this y1 x1 common, which is in, it will become x upon x1 times and a square b square. If we take it to the other side, we get this x upon x1 into a square plus y upon y1 into b square is equal to a square plus this is equation of normal plus. Now that is why this is interesting, because now you are having how many equations of normals in 2D geometry? You are supposed to remember all of them simultaneously without any error. Okay, 21. P theta, equation of normal at P theta. What you are supposed to replace here is x1 by a sec theta, so x a plus by upon tan theta is equal to a square plus b square. Correct? Now 22. Equation of normal in terms of its slope. M. Answer is y is equal to mx plus or minus m into a square plus b square divided by radical a square minus b square m square. This is your normal in terms of slope m. Okay. Okay. So now you can very easily convert equation of auxiliary equations to find out different normals, and you will see, suppose you have been given a point P x1 y1 through which you are supposed to draw normals to hyperbola, then we will put this x1 y1 back here and we will try to write down the equation in terms of slopes, and then you will find that it is a fourth degree equation in M. And therefore 4 normals, if everything is fine, 4 distinct normals would be possible, and there are again cases. So maybe the foot of normal from x1 y1, verify whether coordinates of foot of normal is given by CA square negative sign CA square upon m into a square plus b square, comma CB square upon a square plus b square. These are the coordinates of foot of normal. That completes our basic properties of hyperbola. Now special properties of hyperbola. Of course, first property is S dash P minus SP is equal to 2A, which we have already proved. Absolute difference of focal distances equals length of transverse axis. That is how you can remember. Second, now again we will have to draw a diagram like what we did in case of ellipse. Which we will do now. Let me draw a diagram and then start recording. Now this normal will intersect y-axis at small g. So let me break this y-axis, and this is our small g. Suppose, okay, this is our normal broken here. Okay. So first property that we are supposed to prove is optic property. Normal at P bisects external angle between focal radii. Okay, so what is focal radii? The angle between focal radii SP and S dash P. This is your focal radii. Okay. External angle between focal radii. So if you extend this line, this is going to be equal to this. That is what you are supposed to prove. Alpha is equal to alpha. चला करा हो गया. If you want to prove this, then what you are supposed to prove is S dash P upon SP is equal to ST upon S dash T is equal to minus of SG upon S dash G. Coordinate geometrically, you can do it very easily. Third, I will write down the expressions. Maybe you can do it later. Not we will not spend time now. Cn into Ct is equal to Pf into Pg is equal to A square. Cn into Ct is equal to Pf into Pg is equal to B square. Cg into Ct is equal to Cs square is equal to A square E square. Pg into Pg is equal to Ps into Ps dash. Okay, these are going to be the true statements as far as hyperbola is concerned, which you can take your time exactly the way we did it for ellipse. You are supposed to do it using coordinate geometry, and maybe you can use pure geometry also to prove it. They are similar to what we did in ellipse, so it is easy to remember them. Fourth property, intercept on tangent between point of contact and where it meets the directrix. Intercept of tangent. Okay, maybe I will show you in this diagram. Tangent intercepts point of contact P, and where it intersects corresponding directrix, subtend right angle at focus. Let K. Major angle KSP equal to 90. Maybe you can prove this very quickly. Foot of perpendicular from focus on tangent lie on auxiliary circle. So what do? We should see this. Let us ask Samartha to show us this properly. And then we will move this point P on hyperbola and see whether it traces the circle, auxiliary circle or not. Okay, in this diagram, there is a hyperbola and point E is moving on the hyperbola. Then tangent at E is drawn, which is HI. And H is a foot of perpendicular from focus S on that tangent, and I is foot of perpendicular from S dash on the same tangent. Now if we move the point E on hyperbola, which we will move now, point H and I will continue to lie on auxiliary circle. We can very easily see this. That is what is this property. Foot of perpendicular will follow the circle. Using GeoGebra, we can visualize this, and algebraically we can prove it. Pause recording.